So today we're looking at the anatomy of a linear graph. Now your anatomy are the parts of you. So the anatomy of a linear graph are the parts of a linear graph. Before we get to the linear graph, we need to get to where the linear graph lives. This is where the linear graph lives. This is the x-axis, this is the y-axis, and all together they make up something called the Cartesian plane. So an important thing to understand is that these arrows mean that these lines go on forever and ever, forever and ever. The x-axis is infinitely long, the y-axis is infinitely long, and the Cartesian plane is an infinitely sized flat surface. This is a linear graph. I could have drawn any linear graph, but this is the one I chose to draw. The only thing it needs to be is a straight line. That's the only rule when it comes to a linear graph being a linear graph. Now, there are two really important points that we need to consider. This one here and this one here. Now, this point is where the linear graph intercepts the x-axis, and that's why it's called the x-intercept. And now you probably want to guess what that one's called. If you guess, you'll guess right. That is called the y-intercept. It's the place that the linear graph intercepts the y-axis. Now, the question you want to ask yourself is, can all lines, or do all lines, have x-intercepts and y-intercepts? Can you think of a line that wouldn't have an x-intercept? Keep thinking. Have you got it in your head? All right, I'm going to draw one that doesn't have an x-intercept. There it is, right there. It's a perfectly horizontal line. It's never ever going to touch the x-axis, so it doesn't have an x-intercept. Now, of course, you can probably think of a line that won't have a y-intercept. 3, 2, 1, I'm going to draw it. Now, clearly, a vertical line is not going to have a y-intercept. It's running alongside the y-axis. It'll never touch it. It does have an x-intercept, though, and this one does have a y-intercept, though. Does a line exist that doesn't have an x or a y-intercept? Think about it. 3, 2, 1. I'm going to draw it. No, I'm not. There is no line that you can draw that will go on forever and ever and ever and ever and not touch the x-axis or the y-axis. Some lines touch both, some lines touch one, some lines touch the other one, but no line can exist that goes on forever and ever and ever that will never touch at least one. Now, before I start talking about the next part of a linear graph, I just want to draw one more in here. Alright, that's perfect. I have my last graph here, and I'm going to label these up now. So I'm going to call the first one graph A. I'm going to call the next one I drew graph B. I'm going to call this graph C, and I'm going to call this graph D, just so we can talk about them individually. The last thing I need to talk about is gradient. Now, another word for gradient is slope. And so you can see each of these graphs has a particular kind of slopiness to it. Okay, so we're going to talk about gradient because this is an important mathematical word that you're going to use over and over and over and over again. So it means slope, but gradient is the word that we've got to use all the time. All right, now I want you to draw a car. Imagine a car over that side. Now, look at that car. It's a terrible car, but it's driving in this direction. Now, for the purposes of gradient, we always start our car on the left-hand side of the page and we drive it across the page. Now, what would happen if our car drove along, and then landed on line A and started driving along line A? Well, our car would be driving uphill, wouldn't it? Because it's driving this way and then it hits the hill and it starts driving up the hill. Any line where a car would need to drive up a hill, we say that it has a positive gradient. Now that gradient is a number, and one day soon you'll learn how to calculate the gradient of a line as a number. But for now, it's enough to know that ones where cars go uphill are positive gradients. And so let's jump forward to line D, right? Imagine our car is driving here and then it gets onto line D and starts driving along line D. You can see what's happening with our car on line D. It's driving downhill, which means that line D has a negative gradient. And that brings us to our special cases, our horizontal line and our vertical line. What if our car were to drive along from this side of the page to this side of the page along line B? Would it be going uphill? No. Would it be going downhill? No. Is there any slope to this? No. There is no slope to this. So a horizontal line has a slope or a gradient of 0. And then, you know this is coming, the car is going to drive straight up C. But remember what I said about this car. It's driving from left to right. And if you're going straight up, you're not driving from left to right anymore. You're just driving straight up. The maths behind what I'm about to say is a little bit complicated, but we say that this gradient is undefined. Mathematically, it doesn't make sense. Well, that's a bit iffy as well. But the word undefined is something that we'll talk about in future. But for now, it's enough to say that a vertical line has an undefined gradient. And that is the anatomy of a linear graph. X-axis, y-axis, Cartesian plane, x-intercept, y-intercept, slope.